What is up, everybody? Welcome back. Today we are working on our map that we are making to replace Google Maps. Today's topic is adding roads. So the idea is when I use Google Maps, it doesn't really tell me what I think are sane directions. I say, hey, I live in Vancouver. I want to go from over here, maybe, to over here. And what I would do in this scenario is I would take like this like express bus that goes down Broadway to take it to the train, and then from the train go downtown, right? And he says, no, you cannot walk. Walking is evil. No walking for you. And instead, it will tell me to take some sort of like slow, inconsistent bus, because it goes like, well, the schedule says it's going to come right now, and I believe it. And then you miss that bus and you have to wait like 30 minutes for the next one, maybe more because they're inconsistent, right? And then it sucks, and you get mad. You go, why is it like this? Right? And so I have things that I value in terms of like what I think makes a good trip plan. And so I would like to make an algorithm that like lets me punch in those things, and maybe I feel differently on different days, and like so I want it to be like fairly tunable, right? So like maybe like I don't want to walk down, Main and Hastings in the middle of the night, right? Maybe I don't feel like walking uphill because I'm tired. Maybe I don't want to take the bus today unless it's like way faster, right? There's like all sorts of like tunables like that. And so the goal is we take some data from OpenStreetMaps, we process it, we take some data from TransLink, we process that, and then we stick it together, and we have something that maybe we can use. Maybe. And so, yeah, where we're at today is we are still on like pretty early stages. We have OpenStreetMaps data, but we're only drawing like points. So there are like nodes and edges on this graph. We're only drawing nodes. And so what I want to work on today is like, I want to draw the edges, and then I want to be able to inspect the edges, right? Because surely there's going to be some sort of attributes about these streets and points that will allow us to make decisions in our algorithm and stuff. And so I want to like look at those. And so I think visually inspecting them where I can like kind of scroll over to a street and say like, oh, what street is this? Will be nice. So the plan of action is approximately render some lines. So I think that the data format of how we are going to transfer this stuff between the server and client is actually going to depend a little bit on what is like a sane way of rendering them. So I want to like look at these like OpenGL APIs to like render lines and kind of see what feels good. Once we do that, we can get some data and render the correct lines. And then we can like try to figure out basically which line is closest to our mouse and like highlight that. And then if we get through all that, we can try to show metadata about that thing. And we'll just kind of see how it goes. We'll see how it goes. So we are 2 minutes and 45 minutes into stream, and it is time. It is time to do something. Do some work. So this right now is kind of set up in like two stages. We have like the data processing stage, where this runs like on a server before we serve the site. We do some data pre-processing. So we get like data for OpenStreetMaps. It looks like this like giant fucking XML file. Right? And we like kind of like take this and we like turn it into some binary data. Right now, all we're doing is we're taking like the latitude and longitude of each node and just like serializing it into like this like binary blob. And then we give it some metadata alongside it to say like these are the bounds of this blob, etc. Then there's like the client side, which we have also split into two sections. There's like the JavaScript side that basically binds our WebAssembly code and gives it like some functions that it can call back to do some like WebGL rendering. And then there's the Zig side, which right now doesn't really do a ton, but he is kind of in control of like application state of the canvas, stuff like that. So this is where all of Logic is going to live. Right now we have like kind of like 50-50 Zig JavaScript code. It'll probably turn much more into like 90-10 Zig JavaScript as we go. But we're not there yet. And so if we want to render some lines, right now probably where that makes sense to do is we probably want to like compile. I don't even think we really need to compile a new program. We have like a vertex shader right now, and he says, hey, you give me a latitude and longitude as a position, and I will like draw that according to our given zoom level right now. And then we have a fragment shader, and he says, I'm going to draw white. So really, we should probably be able to draw a line right now between 2 points if we just pick two. So maybe what we should do is maybe we should find some points that we kind of know where they are and draw a line between them. Okay, here's what I'm thinking. There's some stuff that I have not said here that is relevant. So in OpenGL land, you give him a bunch of data. We are giving this data as 2D points, and we are informing OpenGL that we have a bunch of 2D points, right? We say, hey, each point here has like an X and a Y position, right? And you, for each vertex, do something with it, right? And right now we're asking it to draw each one as a point. But if we want to draw a line between two of these points, we could do that in like a couple ways. One is by, in our like big buffer of points, right? You can say like X, Y, X, Y. And you can say like, hey, could you draw between these 2 points? But we don't really want to do that because what we have is like a bunch of points already defined and we want to draw between them. And so what kind of makes more sense for our scenario is there's a way for you to say like, if I want to draw between these 2 lines, I can say, or these 2 points, I can give him a new buffer that says like 2, 1. And I can say, could you draw between these indexes in this buffer? And so I wanted to look at that because depending on how this buffer is set up, it affects how we're going to send the data from like how we're going to pre-process the data, right? Because if there's a way for us to draw all the lines at once, we kind of want to leverage that if it's possible. Because then we don't have to go between like Zig and JavaScript less, and between like browser and OpenGL less. It's just like less work. And so I was looking at this pre-stream, and I can't remember what it's called. It's called something like there's like a sentinel value that you can set. Maybe draw many lines 1 draw call OpenGL. There's a word for it. I can't remember what it's called. Primitive restart index. This is what I'm looking for. Primitive restart index OpenGL. And I want to, or WebGL. I want to see if this is like available to us. Because if it is, then we're chilling. WebGL 2 is always enabled. So we are in WebGL 2, so we have this. Primitive restart fix index. So it looks like we can provide a specific value, basically int max, in our element buffer, and then it's good to go. Okay, so we will figure that out in a second. Now let's try to figure out how we can draw between some points. GL lines draw separate single lines always, if that's what you want. That's not what I want though, because if you look at the data for this stuff, let's look for these like lines. These are like lines of multiple points, right? And so we're kind of we're trying to construct a data format that covers a few key goals, right? We have we have like small, right? We want to make sure that we're like data size does not bloat, so we're transferring as little as possible, and we want like ready for rendering. And so kind of what I'm thinking right now, if this works, is that you should be able to do something like these node references, we can like convert these into indexes into the nodes array. And so we should be able to do like 0147 FF, right? Like something like this. And then we can feed this directly to OpenGL for rendering for like the base map. But this also is like a pretty efficient way for us to pull out like information about the ways or the edges like on a like from the CPU too, because we can kind of assume that we're going to rip the data once on CPU at the very least. And so as we're running through the data here, we can just kind of be like, oh, okay, so I know that like way 0 is 0147, or maybe we'll even say that it's like in the buffer of indexes 0 to 5 or something, right? And then here we can have like, you know, way 2 could be like 2, 4, 6, 8, and we can be like way 1 is at indexes like 6 to 10 or whatever, right? And I think that should be pretty efficient, because I'm assuming also that these ways have like metadata associated with them too, right? So what we're also gonna have in here is like somewhere else we're gonna have to store like way 0 metadata, right? And then this is like a really easy way to tie back like the indexes that we want to render to like attributes about it. And so then we should be able to later say like, you know, if we want to highlight like things that say the word highway or something, then we can like basically rip through our indexes that have that metadata tag, then just issue draw calls with like these bounds. I think that's what I think is this is gonna like look like eventually, but I don't actually know yet. So that's why we're gonna play with it a little bit. Yo, just ran into your stream on YouTube. I work on rendering GeoJSON maps in the browser for my job. Just started learning Zig, so this is super interesting. Wow, it's crazy. The algorithm's pretty good. He figures out what people need. That's crazy. Cause yeah, when I was working on like video, what's it called? Like a video editor, I got all sorts of people coming in and being like, I work on this at work too. I'm like, oh, that's crazy. That's funny. Sounds super reasonable if you want connected lines. Cool. Instruction, dude, I can't read. You should use capitals in your name so that I can break it up or underscores. Instruction cycle enjoyer. Thanks for the prime. Much appreciated. Okay. Let's draw some fucking lines. We'll draw some fucking lines. So maybe what we'll do first is just draw between arbitrary nodes. And then if we draw enough lines, we should see some lines if we do it right. So let's do that. So we have to figure out how to do, I think it's called element array buffer, I think. WebGL. Let's see if somebody can somebody just tell me exactly how to use this? Element array, or maybe it's draw elements. This is the column I'm looking for. So surely this guy's gonna have an example in here. Fuck. We tried. We can probably guess that it's something like we bind our element buffer, shove our data in there, and then call draw elements. That would be my guess. But can we look for maybe a draw elements example WebGL? Surely somebody's done this for us. WebGLfundamentals.org. Dude, they know what I need. They know what's up. Okay, so they do just bind a buffer of the element array buffer, where index buffer is a new buffer that they create. They set the indices, they set the data, and then they draw elements. Chill. Super easy. So it should be pretty straightforward. So I guess we'll do this on initialization. We'll kind of create a bind. We have bind 2D float data. I guess we'll just make a new function that's bind, so in index.js we have bind 2D float data. This creates a buffer that is an array buffer. How do we want to handle this? Because I'm trying to figure out where the API boundary makes sense, right? We don't necessarily want to expose too much low-level details to Zig because it just makes more interop and more pain in the ass. So we could just make a function here that's bind EBO. Sure. Yeah. Sure. Why the fuck not? I think this function is probably unused. Yeah, it is. And so we are gonna say, hey, here are our indices. And the indices are gonna be, ooh, this is tricky. Do we assume a certain size? How many nodes are there? Res grep node from planet OSM. How many? 3 million? So what's uint 16 max is probably too low, right? Right? 2 to the power of 16. 65,000, yeah. 2 to the power of 32. Surely that fits. 4 billion. Dude, powers scale crazy. Did you guys know that? Okay, so we'll just assume that they're 32 bits. That is fine. And then we will create our buffer, bind the buffer with our data. Yeah, sure. So this is EBO. This is element array object. What do they call it? Element buffer. Element array buffer. Element array buffer. And then this is also element array buffer. We bind the indices and we say these are static indices. They're not going to change. Don't worry about it, bro. And then we probably have to do this same shit where we have like the object that is returned by WebGL isn't just like an integer like we want it to be. It's something bullshit. So we do this. We say this EBOs push EBO, and then we return the index. And we don't worry about deleting buffers because we never delete them. Do I have a demo of my product? Dude, using the word product is very funny. It's a toy, and this is all it is right now. It's a map. Unless you are asking another chatter, in which case me assuming you're talking to me is a little bit presumptuous. So we'll call this bind EBO. Where the fuck are we? I'm lost. Here. Bind EBO, and this is going to come from bind EBO. Cool. So now on the Zig side, we can make a function that's like bind EBO, and he's going to return a little EBO handle. This is U32s. But otherwise, I think we're chilling. So wherever the fuck we were before, call this bind EBO. And here, I guess we just like make some lines. So can we just, for now, can we just be like, let's draw 100 lines and we'll just draw them between two fucking nodes? Do we have the nodes available at this point? We do. So we have this already. So we can say map data F32. Oh, we don't even need to do this. We can just make a new array. So indices is going to be a WASM. Do I have my allocator bound to like, no, I don't. Std heap WASM allocator alloc. And we're going to allocate a bunch of U32s and we're going to allocate 100 of them. And then we're just going to say, I guess this has to be failable, so catch unreachable. And here we're going to say indices I is equal to I. Easy. Defer a free of this memory. Not that it really matters, but let's do that. Okay. Then what? We bind indices pointer and indices len. And then we need to stash this thing probably. Which means we need to write down probably EBO as an I32. Because down here, once we have this thing, we're going to draw all of our points. And then we're going to GL draw elements, which doesn't exist yet. And we're going to call it GL lines, which also doesn't exist yet. And we're going to go from 0 to 100. Probably. And I think we actually want like a line strip. Which also we don't have yet, but we'll get there. And here we need to GL bind I guess, does the element buffer get attached to the vertex array object? I'm not sure. It's okay, we'll just do GL bind buffer. And WebGL bind buffer. Nope. Bind buffer. So he takes in a target and a buffer. Okay. So this is going to be like GL dot element array buffer. And he is going to bind the global EBO. Okay. You're pretty sure, yes? So you're pretty sure that element buffers get attached to vertex array objects. So I could get away with, if this is done here, then this VAO is probably already bound, and we might be able to get away without it. But fuck it. Also, fuck it. Maybe not. Okay, so GL draw elements. What is like the call, the API of this guy? He takes in mode, count, type, offset. mode, count, type. This is a, yeah, I think just fine. Mode, count, type, offs. Okay. And offset is a int pointer. Yeah, okay, sure. Sure. Which means we can simplify this guy. Thanks for filling people in on the history of the OS talk. I agree. I agree with you. This is NixOS, and I do not recommend it, but because I do not think that I want you to say, what the fuck, you said I should use this, and it's frustrating. But it's good in a lot of ways. It's like one of those things, you know, in the same way that I wouldn't recommend people use Vim if they're not like, what editor should I use? I'd be like, fucking use VS Code. Just go use VS Code. And then they're like, but I want to use Vim. It's like, okay, if you want to use Vim, you can use Vim. But I'm not going to tell you to because that's insane. That's just like a lot of overhead for for someone who's just trying to like write code. Okay, we have GL draw elements, and I guess this is gonna go to draw elements. Do we need to go? What does draw arrays do here that we? Oh, I see. Draw elements. So this just gets like hard bound to GL draw elements, which is what I want. That's what I want. And we also need bind EBO, which we already have. So there's a chance that this works without us rebinding the buffer down here. It's kind of like bad practice to do it that way, but you know, shut up. What is he about this thing? Mode, count, type, offset. What is type? Unsigned byte or unsigned short? Or unsigned int. We need unsigned int, which is only using this, but I think this is probably activated in we'll hope to God. We'll hope to God. So we'll use GL unsigned int, all caps. And the offset was the last thing, so offset 0, and the count was the second thing, so 100 here. Yeah. Now I'm just using mscript which has bindings generated for you. Are you doing the bindings from browser calls manually there? Yeah, I'm a kind of a fan of getting as low level as we can without getting so frustrated that we stop doing what we're doing. Right? I like the idea of knowing exactly what's happening, and I feel like when I've used like Rust's WASM bindings in the past, it was like hiding a lot of stuff from me that I kind of like makes it hard to make good decisions in my mind. But also we're a little bit nuts over here, and we make decisions that we shouldn't make in the interests of learning and fun over the interests of being productive. Okay, so we're missing GL line strip, so I think that we can just like yoink some constants from the OpenGL or the WebGL spec. That's what yesterday we yoinked them from the what's it called? Some like Rust crate for WebSys. Where the fuck are my constants? I'm in the wrong file. That would do it. But I did find this link, which is a very nice link for us. Oh shit, I shouldn't cover that because last time it crashed my fucking computer. And we are gonna look for what constants are we missing? Line strip. So this is 3. So is this how we write code? Maybe. And then what else are we missing? Unsigned int. Which is this. Perfect. Have I tried Apple Maps? Sarcasm. Yeah, I mean, we're not gonna pretend that what we're doing is it's almost more fun not to try hard to solve the problem, because then we get to solve the problem ourselves. Am I in the wrong folder? I am. Refresh. Okay, so what do we expect to see happen here? I guess let's not draw the points, because if we draw the points, then it's harder to tell if the lines are there. Fuck off, fuck off, fuck off. Did I not say don't fucking draw the points? What the fuck is going on? Something here is not right. Something is not right at all. Zig open. When was it generated? 1425, so that's right now. I don't understand. So this is very clearly still drawing points. But there should be no code anywhere that calls draw? Unless in index.js, I accidentally left something in here? No? So like, what the fuck is going on? Seriously, what the fuck? What the fuck is happening? Network, disable cache, refresh. Dude, what the fuck? I was Control-Shift-Ring. Is Control-Shift-R not like hard fucking refresh? Like, it's so fucking... Fuck off, man. Do you build all your projects on web and native, or you're focusing on WASM 100%? I don't really know what the difference between those are. I'm interested in the idea recently of using the browser as UI, just because it means that I only have to learn one UI framework, and it will work on every context ever, including like embedded devices, right? Assuming that I have a TCP connection, then I'm good to go. Even if I don't have a TCP connection, maybe I can write out an HTML file every once in a while and like open it as like a capture of state. So I like that idea recently. I also like the idea for this project specifically of being able to do everything client side so that I can host it like statically. I like the idea of static hosting. And I also want this to be able to be like used from like my phone or from my desktop. So like having a website kind of makes sense there. But I don't know if I would lean towards this type of work for everything. Difference, I have native or web builds and I keep native going. My projects are native and I keep native going. Are you saying like you can build your project using like an adapter for a WebGL canvas in WASM, or build it with like a GLFW window natively or something? Because I do like that idea too. I do that sometimes because it's useful for like performance testing. The ability to use like perf directly on like is very, very nice. So that's not set up here, but I probably will hit that at some point. But only when we need it. Zeus time, thanks for the prime. Appreciate it. Okay, what's next? So we are not drawing, well, we're not drawing anything. What happens if I try to draw some elements? Okay, so those are definitely some lines. That's a good sign. So now if we want to try primitive restart, we should just be able to like kind of every once in a while here, like inject a 0xff. So maybe we'll do like if I%4 indices I is equal to 0xff. Else we use the index. And if we understand everything correctly, if we understand everything correctly, we should see line segments of length 4. Or 3, I guess, if everything 4 nodes. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So it looks like we understand to some extent that we can basically just shove some FFs in between our data, and we get lines. So all we should have to do now in order to get the correct lines is, here's what I'm thinking. We have like, right now we have buffer of like floating point data. So you have like 0.1, 0.2, 0.3, 0.4, whatever. And these are like kind of split in pairs. So we have like, each of these represents 1 point. What we can do is we can just kind of like tack on the end of this guy some like basically list of node IDs. So here, like if we wanted to draw a point between these guys, we would tack onto the bottom 0, 1, FF. And then we'll just do that for every single way they're called in our data. And then we should be able to just flag basically where this point data ends and the like line data starts. And we should just be able to like rip that with 1 or 2 extra lines of code. once we get the data, right? So the hard part here is then structuring this data. And so I think this is all fine, because if we're going to need the street info in the CPU. We're going to need it for like path planning, right? But we can easily extract that from this format by just kind of like walking and looking for FFs and using those as like splitters in the same way that the GPU is doing it. So it's fine. I think it's fine. We'll call render some lines. Done. We have rendered some lines. They are not useful lines in any way, shape, or form, but they were useful in that they taught us what to do. Now let's try to render the correct lines. Okay, so in our data processing script, we kind of have this like start element callback that gets called every time we here, how do I say this? If we open up this XML data, basically every open tag gets called with start element. Now, if we were going to process this data correctly, we would, look for the start of a way, then look for node tags and append these to that specific way, and then look for the close of the way and say, okay, this way is finished. But if we want to like abuse the format of this data file, in reality, we kind of know probably that every node is only tied to a way. Maybe. I'm actually not sure. Let's look at the relations. I'm pretty sure relations have members and tags. Yeah. So for now we can get away with just looking for every time we see a way open tag, we'll throw a 0xFF, and every time we see a node tag, we will put that in our list. And I think we can also leverage the fact, I think that I saw somewhere that the data is guaranteed to come in order. OSM data format. I think I saw that all nodes will be present in the XML file before any way. So we can actually just assume, as we are parsing, that the nodes are available. I think we can assume that. Well, let me look. I saw somewhere. Oh, certainties and uncertainties. You can be certain that blocks come in this order. Right, an OSM, okay, so contents, an XML file, blah, 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 an OSM element containing the version of the API, blah, 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 a block of nodes, a block of ways, a block of relations. And so they're saying here, you can assume that the blocks come in this order. That is a important part of the OSM data format. So it's kind of like the OSM data format is like, it's XML, but it's like a subset of XML. It has extra rules on it, and it's that they come in this order. So yeah, I think that we're chilling enough. We don't have, if we were going to be good, we would track this shit properly. But instead, we will not be good. And what we have to do here, we have to be a little careful, is the ways reference node IDs, right? They say like ref node number 252-50693. But we don't have all nodes in the whole world. We only have the nodes related like to Vancouver, right? And so we have to keep track essentially of the node IDs and which indexes they're in, and then we convert these node IDs into indexes into our array. I think that should be fine for us. So we can come here, we can say like, as we iterate, we are going to keep track of a node ID IDX. Node ID IDX map. So basically a mapping of the node ID to its index in our output. And this is going to say stood hash map. Nice. We do have hash maps. And they go from U64, probably. Does it say what these are? Node IDs. IDs. Element IDs are non-negative. We're not allowed to assume that. So we should use I64, I guess. And we will point I64s to U sizes, where in our output they are. As we iterate, we're gonna say, okay, so num nodes is not touched anywhere, but we could touch it. We could say basically every time we get a new node, every time we see the word node, we increment num nodes. So we say user data num nodes plus equals 1. Then we say we have to parse the node ID opt. This is going to come out as a string. He starts as null. And we look for the field name, no ID, I think. Maybe? Yes, ID. So this is going to be the node ID optional gets set to field val. Then down here, we can say that the node ID string is the optional thing. I wonder if like we should crash in these cases, but fuck it. Node ID comes from node IDs, and this is parsed as an I64. Then here we just insert into our user data node ID index map, put add, insert, push. What is the API to hash map here? Can get or put value. Put. So we put our node ID to the current number of nodes. There. Chillin'. So at this point, we should have, at the end, after we've gone through every single node, we should see nodes. We should have a list of node IDs. Node IDs to node indexes. Perfect. Now we have to start parsing ways. So here, I guess we're gonna kind of move all of this stuff probably into like a function here. Handle node. Is this where I want this to go? Yeah, blaze it, I guess. Seems fine. So this is gonna take in basically this stuff. And this is gonna take in user data. Okay, and then basically everything down here goes here. And just everything, and here I guess we can just call this user data, even though usually we use the word self. We can use the word user data there so that we don't have to rename anything. He's saying that name C isn't used, which just seems like a blatant fucking lie. I also don't see it used though, which is confusing. Oh, because name C is used to determine if we are a node. But we do care about the attrs, so it's not a blatant lie. He was just telling the truth, and I didn't believe him. And I should believe him when he tells the truth. So here we can say handle node, and we pass in the attrs. Boom. Now we can say if std mem equal way, we're gonna have to do something. And if we see nd, we're gonna have to do something as well. So I guess when we see the first way, we want to flag somewhere that like we started there. So we're gonna do something like way start is optional byte offset into the file. Okay, that makes sense. And so now we're gonna say if, I guess we'll just say handle way here. No, we don't. We can inline here. It's gonna be like if user data way start is equal to null. Here we log how many bytes we've written. Which I don't know if we have that information available to us, to be honest. Yeah, we don't really. So instead, we could like count how much data we've written as we go, but I don't want to do that. Instead, we can just say that it's user data wait start is equal to none. Oh, in fact, we don't even have to calculate. We don't even have to calculate this here. We can calculate this at the end, actually, very easily. It's just the number of nodes that we wrote. times some amount of data, right? So we can come over to wherever the fuck we read our metadata, which is somewhere. It is somewhere. Here, our metadata, he's just gonna have the num way start offs, end nodes. That seems reasonable to me. And he's gonna start at 0 here, and then we're just gonna set this at the end. So here we're gonna say that the metadata, user data, metadata, end nodes is the num nodes times 8. The number, like the floating point x and floating point y, each of those are 32 bits, so it's simple. It's simple. Okay, so now if we see a way, we can just, if we see the word way, we write 0xff. I guess actually we want to do this on exit. It doesn't fucking matter. It doesn't fucking matter. It doesn't matter. I guess it probably makes more sense to do this at the end of a line, not the start, but fuck it. We have what we have right now. We could add like an end element thing, but I don't want to because I'm fucking lazy. So here we just have to write out we want to write an int, I guess, of this. Write int value and the endiness. The endiness doesn't matter, but we'll write little here. How are we handling errors everywhere else? Yeah, we just catch unreachable. Fine. Fuck it. Doesn't matter. Otherwise, we have to look up the index. Right? So here we're going to say user data. So first we're going to look for the ID. So we have to like find ID attribute. Then we have to parse ID attribute. Then we look up in the map, write it out. So this is like write ID, like node IDX. Const node IDX is equal to user data node ID IDX map get ID node ID. Here we have node ID is equal to find attribute value of ID. And this is going to be like the string probably. Then we're going to like say that the node ID is a std format parse int I64 of the string base 10. So now we have to like write this. So this is going to take in like a name, the ID, the key, I guess is what it's called. And we're going to take in our attribute list. And we're going to turn an optional string. And this is just going to be similar to what we did here. So we'll just copy paste it all. And we need an I value as well, I guess. I will allow it. And if the field name, if we see a std mem equal of field name to key, we return field val. And if we get to the end of this, we return null. All right. Should be good. Should be good. So this actually looks like it's not yelling at me. There's like a non-zero chance this compiles. Non-zero? I'll take it. Non-zero is pretty good. Std hash map. We need to say auto hash map. I think it's called auto hash map. And then surely we have to actually initialize that guy. So this is like a auto hash map from i64 to usize, initialized with some allocator probably. Probably. Error union is ignored at 46. Sure. I don't know. What else? Expected 2 arguments at 90. So this needs to take in the atchers here. And compile error cannot parse float into a non-floating point type. Where the fuck is that coming from? That's coming from... What the fuck? Parse float. Oh. Oops. And this has to be base 10 as well. Whoopies. Get node ID found. Expected type i64 found. Error blah 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 at 92. So this has to be probably catch unreachable as well. We're being pretty liberal with the error handling here. Don't yell at me. Expected type u32 found usize. Okay. Fine. We are assuming that we have enough there, and it'll crash if we don't. So, not if we build in release fast mode though. Let's change this to release safe so that we get like some form of error handling, like a little bit. We want release mode because we want it to parse fast. But I was pretty. I wrote a lot of unreachables and intcasts and stuff that won't crash in release fast, but they will in release safe if I remember correctly. Hopefully, I do. If statement is almost getting complex enough to flip to some sort of split functions. Yeah, I agree. Attempt to use null value. Whoa. Can we just like... Where? Can we... I guess we GDB this thing. Well, maybe can we just build this thing and run it manually instead of running it as part of the build script? That probably makes a lot more sense. Can we do like b self b install artifact exe? Okay. There we go. There we go. Okay. So, oh my god, fine. We have to pass this thing, let's get mad. Fine. I see how it is. Okay. So at least now I should have good zig out bin preprocess of res planet. Okay. GDB R backtrace frame 6. What the fuck? Oh, alright, my bad. I need to run with it's GDB -- args to get the args passed on. Index out of bounds? Oh, because I need to specify an output as well, probably. What is my, like... He's expecting args 2, args 3, args 1. So this is metadata out, and input. Right. So it's out bin and out JSON. Much better. Much better. Okay. He is mad at this. Whoa. Why? What the fuck? What's he mad about? Attempt to use null value? I don't see it being null value there. Am I crazy? Am I missing something? Up, 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 up. Oh, trace here? 0? Oh, so maybe we got kind of p info locals. No locals. Ah, fuck off. Maybe it's getting stuck about something else. That's very possible. Okay, so this is Did something get corrupted? If we go to main, user data, find node function can return null. That's true. That is true. It can do that. But it's like if the location that it's crashing feels wrong to me. You know? So I want to see user data, is that what it's called? So data is at this address. And CTX, it's not that address. Surprising. So something's getting fucked up. Oh, because wait. I don't have a data pointer there. So what the fuck was I just logging? Oops. It's called user data. It's called user data. My bad. Frame, oops, sorry, BT frame 14. Oh, frame 11. Here we go. Okay, this is 1228. 1228. 1228. So this should just be totally fucking fine. There's the fucking GDB must just be broken. That's very possible. It's very possible. Like if I do this, does that fix it? There's a possibility. It's possible, it's possible, it's possible. There's a lot of things that could be going wrong here. Yeah, okay, so that was it. I'm kind of curious now. Maybe this just works. Can we like look at the data? So map data JSON has an end nodes byte offset. And we could maybe try to like look at that. So is there like, I think it's a, how do we skip bash skip and bytes of file? I think there's like a way to like, they're just saying, oh, tail plus C. Tail plus C plus this of map data bin x dump dash C. That looks concerning, to be honest. That does not look good. That does not look good. So it's possible that we done fucked up here. And it could be that the ID attribute is never being found. Because I think it's actually called ref. I think that's probably why it was crashing as well, is because we were looking at the wrong thing. Instead of checking, right, I could look at the XML and check the file, check the key. But instead of doing that, I will just guess and then get mad when it's wrong again. How does that sound? That sounds great. Okay, can we do that same? That looks a lot better. That looks, oops. Can we, map data JSON? So that's the same tail, skip that much. And can we look for, okay, so we see like some tags of FFFF in here. They're offset by 1, which is, I think, correct. I think, so we're seeing here that we have like a way that's like 1, 2, 3, 4, 5 points long. And then a 0x FFFF. Which I think might make sense here. We might want to pad this so that it lines up, so that we don't have to like, I imagine this alignment is going to be a problem. Let me think. Yeah, I'm gonna bet that we want this stuff to be 4 byte aligned. So here we can track first way offs is going to be a u64 equals 0, or null. Then down here we're going to say if way offs is equal to null. We are, user data way offs. We are going to do this calculation. So we're going to say user data dot way offs is no, something about this doesn't feel right to me, actually. Because if we are 8, we should be 8 byte aligned at this point. Right? So it could be that the hex dump was just fucking stupid. Whatever I wrote in, like, that tail command might just be a little bit offset. I might have just been off by 1 or something. Because it should be 8 byte aligned. Should be. Let's look again a little closer. So can we do like echo hello world test.text. Then we want to look at like the last. We want to take out like the HELO from hello world. Ah, it is off by 1. It is off by 1. So this tail command that we were using before, we should add 1 to that. And now we should see that the way end markers are aligned. So we're chilling. We are chilling. So now in here, what we should be able to do is we should be able to draw line strips, but instead of drawing a line strip from this thing that we did here, off by 1 error. Yeah, it's classic. We're classic. Instead of doing this, we kind of just yoink it from like our global data that was been like the data that's been fed into us. So this is going to be, first of all, this is wrong. This map data F32 now has to go from the input data from 0 to metadata end nodes. And this is in bytes, so we're chilling. And then our indices goes from global map data from global metadata end nodes onwards. So we have to call this, is going to be like called like const index data. This is going to take in index data pointer and index data len. And we have to cast this to a slice bytes as slice. We have to cast this to U32s. Which I think might work. I suspect that there's some sort of syntax error in there. There sure is. Expect type usize sound U64. Right, so end nodes, we kind of have to incast this. Just hope for the best. I mean, we don't have to just hope for the best, but we will just hope for the best. And then down here, this has to say items here, and we probably have to incast this again. And we could do proper error checking, but instead if we just fucking blazed it, you know? Can we align cast this as well? So I think that's here. He's mad that the alignment is not guaranteed, but we kind of say, hey, don't worry, bro. We got you. We know that it's aligned at 4 byte boundaries. We can guarantee that for you. We can't actually guarantee it for him, but we can hope that we can guarantee it for him. Are we in the wrong directory? We are. Fingers crossed, fingers crossed. I think every time we build from another directory, this path gets like reset a little bit in some way. I don't know, there's something happening here where it's like reprocessing the data when it doesn't have to. Nothing's happening. There are some lines here. Oh, we have to say which lines we want to draw. We need to draw how many lines. It's like map. It's like end nodes. Okay, so the num elements. Const num elements is the map data len minus end nodes, and this has to be divided by 4. This is the number of elements. And there's all sorts of errors that we just kind of dodged there, but oh wait, that looks, those are roads, and those are buildings. Okay. Wait, that's crazy. Okay. So I think this is right. It's just that we're getting way more data than I thought. Like, way more. But, like, if we try to look for, like, a... Yeah, this is, like, the airport. So here we're actually seeing, like, is this, like, the landing strip for airplanes? Might be. Man, that's crazy. Yeah, that's interesting. So we're seeing stuff that I don't necessarily care about. And so we're definitely going to have to filter out a lot of data. But this is super fucking cool. This is super cool. Can we go downtown? Yeah, that's downtown. Is this, do they have, here's BC Place, big stadium. Here's Science World, where the ball machine originated from. It's fast too. Yeah, it's pretty crazy. It's pretty crazy that we just have like the whole data for the whole city. And we're just like, fuck it. Does it have all the place names? That's a good question. I don't know how we go from... It would be interesting to see if we could find like Science World or something in there. I wonder if it's just like in the fucking data. Like if I look up like science. Okay. I mean, Science World's in here. And it is attached to ways. It's also attached to a relation. So what the fuck is a relation? Oh, so this is like a station. Interesting. Okay, here's what we should do. Here's what we should do next. We can try to figure out some stuff about this for sure. But I think what is going to make a lot more sense is to try to like discover this stuff spatially, right? So what I think I want to do is I want to like highlight, I want to be able to like go here and like put my mouse on this line. And if we put this mouse on this line, then we can like, we can figure out which thing that is, right? Now the question is how the fuck do we do that, right? Because like some of these lines are like really long, right? So we're gonna have to do something like, we need like some sort of like spatial data structure, right? Something that we can easily go from like longitude and latitude to like thing that intersected it, right? Right, we're gonna go from, yeah, longitude and latitude to list of way IDs, I guess. So we're probably gonna do something like what my brain says I should do right now, which may be stupid, maybe not stupid, is just kind of like chunk this thing up into a grid, right? And hit test as we add ways to, as we process every single way, just hit test it with every cell in this grid. And then say, then if it intersects, then we can say it's in here, and then we'll just kind of tune the size of this grid to be small enough that we shouldn't see more than like a couple hundred intersections at once. Then when we go to then what we can do is we can kind of like hover the mouse in an area, and we can just rip through every line that it sees, right? And find the closest one. Won't that stop working when you zoom in? Not if we work in longitude-latitude space. Which maybe we shouldn't. Maybe it makes more sense to work in like unwrapped space, but we don't have unwrapped space yet, so we'll work in longitude-latitude for now. Quad trees. The fuck is a quad tree? Somebody, is this just what I made up? Looks very similar, except that they are, they're kind of like allowing higher resolution when necessary, which is a good idea, for sure. But I think that we might be able to get away without it at first, right? Like what this is good for is if you have like really sparse data somewhere, or maybe we want like more resolution where there's more density, right? But I think that what for our purposes, it's probably good enough to just not worry about it. So let's just, yeah, let's do this. Let's do this. So I guess let me think. I'm just sorry. I'm just thinking. I am thinking. So we're gonna want to do something like, I'm trying to think like, where does this belong, first of all? Because if we do it during like data processing, there's like more data that has to go over the wire. But if we do it on like initialization of the web page, like maybe that's like a lot of wasted compute. So maybe what we do is we benchmark approximately how fast it is to just like, first let's just kind of see like, is it feasible for us to just walk every single line segment on CPU on initialization? How fucking slow is that? That's probably like a good thing to like know about. And maybe for now we can sort them based off of let's not worry about hit testing right now. Let's look at the two ends of the line, right? I think that there are cases where, like, you know, if our grid is like this, we're gonna want the to see this line when we hover over it. But for like our initial testing of if this concept works, we can just work with the corners of the line and use that as our approximation. Welcome, Raiders. Hello, everybody. What is up? We are working on a map. So the idea is approximately that I don't like the way that Google Maps tells me how to get places when I take transit. And so we are building our own map where we're going to be able to write our own path planning algorithm based off of things like bus schedule consistency, right? Like if we were to monitor bus movement over a long period of time, we could probably approximate how likely they are to be on time, and we could use that in our algorithm. We can tune it to say things like, I don't want to walk through, you know, an unsafe area of my city late at night. I don't want to like walk uphill right now because I'm tired, right? We want to be able to like tune all these things. And so the first step to doing that though is like understanding the data. So what we have here right now is we have OpenStreetMaps data that we've parsed. We've parsed this like, I think it's like a 500 megabyte XML file. Let's see. Yeah, 420 megabyte XML file that like is about, you know, related to where I live. We pre-process that into a binary blob of points, and now we have just added, before you guys got here, lines. So what happens here is we have like, you know, in this thing, we have a point here, a point here, a point here, and a point here. We bucket all these points, we give them IDs, and then we have these like list of line segments essentially where we say like, oh, so we want to draw a line between point ID 45 and 46, 46 and 47, 47, 48, and 49, 48 and 46, whatever the fuck the first one was. Yeah, and so what we want to do now is we want to figure out. So we were looking at like this guy right here. This is Science World, a beloved place in Vancouver. He's more circular than this, but you know, he's a little squashed here because our mapping is really shit. All right. And we were just looking in the data before you guys got here, and we were looking at the fact that if we look at here, there is the words Science World in this file, right? And we want to be able to say like, okay, so Science World is like a known thing in here. Can we like click on this and like discover what it is? And so to do that, we have to find some way of determining which line segment is close to our mouse. And so we were just talking about the idea of like, maybe we bucket the map into grid cells and we try to figure out, we eventually will want to like hit test where a line goes through, and we'll say like, okay, so we've like this line, each of these points, each of these cells is going to map to this line. But for now, we can just do this where we say if a line goes from here to here, this cell will map to that line, this cell will map to that line, and everything in between won't. So that's what we're going to look at. That's what we're going to look at. Sounds like a cool project. Also, the video encoder hates you when you show the zoomed out map. Your face gets quite a lot. Oh, that's pretty funny. Well, if the map is much more important than my face, who cares about my face? Let's look at the map. The map. We love maps. All right. Yeah, so let's try to figure out. We were talking about before you guys got here whether or not it makes sense to do the the data processing on like the client side or the server side. Like, because sorry, there is no server, right? But there is pre-processing. And so we could do it in pre-processing, but that means that there's more data to send, and so it would be interesting to see how slow it is if we were to do it on like initialization of the site when you load it. All right, got a jet. Hope you great stream. Yeah, have fun. Later. Thanks for the raid. Okay. So we want to walk every way. And right now we don't really have a way to walk every way. The way that these things are stored, so right now we don't actually know on the CPU about anything on here, right? Well, we do kind of. But like all we do right now is we take the data that we got from the pre-processed data and we would go like, here you go, OpenGL, could you draw this please? And because of the way that we format the data by basically segmenting the stuff with 0xFFs, like max ints basically, the GPU knows in one draw call to say like, oh, okay, like I'll ignore that shit. I guess it's like the GPU is probably a 2 level. Like OpenGL knows to dispatch that as like multiple line segments. But we can just parse that. Is OpenGL better suited for this test versus DirectX? Well, there's no like DirectX in the browser, I don't think. There might be some like ActiveX plugin that you could use on Internet Explorer like 5 years ago, probably more like 10 years ago. There might be something like that, but the web browser has this like WebGL thing that maps very, very cleanly to OpenGL. It's like very, very close. And also I don't really know. I mean, I don't write games. I don't know shit, right? Like let's be honest. I don't know what the fuck I'm talking about. But my gut says that like in any of the like major like game engine-y things, I don't really think that we should assume that like, I don't think that like going from OpenGL to DirectX is like going to give you a performance improvement necessarily. There might be features of those rendering engines that like have different capabilities, but I would think that they're like overall kind of the same. That'd be my guess. But I mean, what the fuck do I know? I've never benchmarked them or looked. It's just my guess. Okay, so I guess we're gonna need to do some sort of like waiter. I think the Rube Goldberg machine qualifies a game. It is a little bit like a game. It's a lot like a game in some ways, but not in the way where I would have any idea how 3D game engines performance are. You know. So we're going to DirectX latest versions are definitely more powerful than OpenGL, but OpenGL is not a dead end. It can do a lot. Yeah, that's. I could see the argument that like, if you're writing Unreal Engine, you're not going to be using OpenGL unless like you're trying to use it as a fallback for something else, right? Like you want an API that gives you like more fine-grained, lower-level controls. But if you're just like, I'm a dumbass like me, OpenGL, wonderful, simplest way to do GPU. Okay. So here, when we did our XML parsing, we said every time we see the start of a way, we put 0xFF. So I guess here we're gonna say, we're gonna have some data. It's gonna be a bunch of U32s. And these U32s represent node IDs. Here we're gonna have our index into that thing. That makes sense. And then we're gonna have a next call. And he's gonna return something. He's probably gonna return like the way ID. He's gonna return ID, which is going to be not the OpenStreetMaps ID, but like our like index into some kind of like way map. Maybe he doesn't return an ID at all. Maybe not. Maybe he just returns the start position in data and the end position in data. Yeah, and then we'll turn those into like an array later. That seems reasonable to me. That seems reasonable to me. And all we're gonna do is we're gonna say, if so, this is gonna take in self, and he's gonna say like, if data I plus 1 is equal to ff, then that means that we're on the last node. Maybe what we do instead actually is we just say I plus equals 1 at the beginning of the loop. Yeah. Because we know that the first byte should be int max because of the way that we like organize the data before. Instead of taking the start at the end of the line, we take the start of the line. So we can just kind of like skip the first byte. We don't give a shit about it. Then we say, hey, if I is greater than or equal to self data len, we're done iterating. So we return null. We need to end this bracket, and this gets returned nullable. Then we say, if the data at this thing, then we're done, and we can say that we return. I guess here we kind of say const start is equal to I. Then this all kind of happens like in a while loop. Actually, we don't need to do a while loop. We could use some sort of like std mem index of scalar. Yeah. So we can kind of say we can kind of hope that the standard library has a faster version of this than we write by hand, right? This is like a generic thing. We're looking for a thing in a thing, right? So we're looking for, in a set of U32s, we're looking for the index of 0xFF from I onwards. Okay. If we don't find this, then it is the data length, because the last line is not going to have he's not going to have an end tag because we're taking the start of lines, not the end lines. Yeah, so we have start, we have end, and then we return start equals start, end equals end. Okay, that's simple. And then just at the beginning here, we just say if self I is greater than or equal to self data lang, we return null. And this should just iterate all of the ways and give us their start and end positions in the buffer. Yeah, so now we just need to like initialize this thing. And this is going to be initialized and return away IT. He's going to be initialized with the data, as well as the way start offset. How do you len? LOL, this stuff. I bet by len you mean learn, and how is by like you're watching it, right? We just do this a lot, and eventually you pick stuff up. Not like you being me, right? I'm saying like the colloquial you. Eventually, if you write enough code, you have a guess on how to write the next piece of code. You know, you know. Okay, so on initialization, we're gonna do something like const way iterator variable way iterator. He's gonna change. Whoever typed today in chat, you can see it in the top right. It's a little small, I apologize, but it's up there. It's up there. Just like an LLM. Well, LLMs don't really learn as they go. It's a lot not like an LLM. I guess it's, but I do think that a lot of like you can think of our brains a lot like machine learned brains in a lot of ways, just with a really high learning rate. we tend to like really overfit to like the most recent data, but it is very similar in my mind. At least I can use machine learning as a mental model for what I think goes on in my head. It's not a perfect model, but it's good enough a lot of the time. Okay, so this is going to be related to the global data that we got from JavaScript. It's called map data. And the start offset is just this thing. Boom. Okay, and so now we can iterate these things. So I wonder, like, for now, if we just count how many we get, if, like, how fucking slow it is. So we can say num ways is equal to 0. And we're just going to say while way it next. We're not going to look at the thing. We're just going to count num ways. And here we'll say print num ways is this. And we can see just how fucking slow this is going to be. Fuck. Never compiles. It never compiles because we need to intcast this thing. So this is going to be... let me think about this. We can just take an index data here. And then here we don't need to use a way start offset. We can just initialize to 0. Because we've already sliced this thing to start from where the ways start. So we can see that. We can try that. Okay, that was actually really fucking fast. Like, one Mississippi, like, it would be interesting to see actually, print hi mom. Right, we can see approximately, yeah, I mean, iterating all the ways was like relatively instant. Right, there's there's way more time spent fetching the data for the map over the wire. So I think we are chill to do some sort of data processing. It depends on how expensive that processing is, but we can do something here. We can do something here. So maybe we add this concept of like spatial lookup. I don't know. I don't really know what I'm gonna call it. Nobody knows about console time. Well, we don't need to actually benchmark it. We just have to see, like, is it fucking slow? You know? Do you know WebGL? I'm assuming by no, you don't mean NO like you said. You actually mean KNOW like you meant. And by knowing WebGL, I mean, we're using WebGL right now. The question of do we know it is like, you know, like maybe a little bit, like not that much. But we were using it, right? I think that like it's one of those things where it's like if somebody asks you if you know C++, your answer as a beginner is like no, right? And your answer for some amount of middle is like yes. And then you hit this point where you're like, oh, I don't know C++ at all, right? You start getting into like, there's like a valley where you go like, oh shit, like if I tried to write like anything that uses template metaprogramming, I'm probably fucked. Maybe I shouldn't say I know C++. And then you get like past that again and you go like, I fucking know C++. Nobody fucking needs that shit, right? So, you know, when you're like, do you know WebGL? It's like, I don't know, man. I have no idea where along this line I am. I feel like I know some stuff and not a lot of it. You know? Okay, so we're gonna like break up this thing into like slices of longitude and latitude, right? So we're gonna have like some array, like probably a constant thing. We probably don't, this isn't gonna be like a dynamic thing. We're gonna like predetermine how big the slots are. So we're gonna say that we just have like buckets. Buckets. And they're gonna be a bucket. What's gonna be in these things? Who fucking knows? Elm. What's an Elm? He's gonna just have like way IDs, I guess. So we'll call this like way lookup. Okay, so we have buckets and they point to way IDs. Sure. Yeah. Okay. And then what? Then what? We're gonna say like how many buckets are there horizontally and vertically? So let's think about this. There's two ways we could do this. One is by we could specify the size of the bucket in degrees, or we could say how many of them are there. And I think saying how many of them are there are better, because then you can do integer math and then just do one floating point conversion at the end. And from that time where we re-implemented floating points by hand, we're like, holy shit, float 32s, when you fucking add them a bunch of times, you stack errors like crazy. So let's do integer math. So we'll say num let's say like buckets per row as a use size. I can only make a square, but if you go past that, then it's insane. Well, I mean, going from square to anything else is like kind of like the same shit, right? Like we did this, and all we know how to do is draw a line. Right? That's all we know, and we just drew a lot of lines in a row. Like, what's the difference? Okay, buckets per row, we do this, and then on init, we're probably gonna like take in our like metadata, and we're gonna use this to try to like look at the bounds of the thing. So maybe we're gonna say like, I wonder if it makes sense for us to maybe hard code buckets per row as a constant, right? We can just say we have 100. Okay, that seems reasonable to me. Then we can like kind of determine the mapping later. Sure. Do we need anything to go from max lat min lat? I guess we kind of want to like store like how that maps to longitude latitude, right? Because somebody's gonna come in here and they're gonna say like, hey, I want to know which way IDs are at a given position, right? So I'm gonna give him like, I'm gonna say like, I am at this latitude and this longitude, and I'm gonna be like, hey, can you fucking give me a bunch of U sizes? Right? That's probably what's gonna happen here, which means that we need to know how to go from like bucket ID to this, and that these buckets actually have to be like nested. So this is probably gonna be like a bunch of array lists of U sizes. Probably unmanaged, and we're gonna store an allocator here. Probably. I don't fucking know. We're filling it out as we go. Who knows what's actually gonna happen here? But this is the process for me. We just kind of guess until we get to the right answer. Hey, Typecraft, thanks for the raid. What's up, you guys? You guys want to see where we're at? I think you guys came in the other day while we were already working on this, but we're working on our map, okay? And look, we've kind of drawn Vancouver. Look at all these lines that we added today. Look at that. That's kind of fun. And so right now we're trying to figure out how to basically go from like where my mouse is on the screen to which one of these roads is close by. And then once we have that, we can like kind of use that information to inspect metadata that we have from OpenStreetMaps. And then from there, we'll do something more interesting. But right now we're just trying to figure out what the fuck we're looking at. And so we're kind of thinking we're going to break this thing up into like grid sections, and we're going to say which lines are in this section of the grid. Hand wavy. And we're just going to figure out what that looks like. Yeah. Okay. So I guess we're going to walk all of the line segments. Yeah. And we're going to push them into this thing. That seems to make sense to me. And we're going to push its ID, its latitude, and its longitude. No. He's got 2 points. Let me think about this. Sorry. Okay. Something that I didn't consider until right now. These lines are multi-piece, right? They go here, 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 here. Now the question is, do we want to look up an individual line segment? No, probably not. We probably want to look up like the street or the way as they call it, right? So if this is like 1, 2, 3, 4, 5, 6, and I hover here, highlighting the whole thing is reasonable because we're looking at like per street tags, not like per section of street tags. So I think that's fine. Now the only problem here is we need to actually, we do need to actually store which line segment we're looking at. Because we need to be able to quickly match mouse position to line, right? So if I have like my mouse like here, and I have like, you know, a street that goes like this, and a street that goes like this, I basically have to be able to do like the vector math to say how close am I to this and how close am I to this. And if I only store like kind of like this whole thing as one, then I have to iterate a bunch of stuff that doesn't matter. So there's something there, but we're skipping a lot of this problem by not caring about this right now. We are only looking for points on the line right now to simplify the problem for us initially. And because of that, we can just say, hey, this ID is tied to a specific latitude and longitude. Yo, what's up? So when I push, what do we have to do here? We basically have to figure out which bucket. So there's going to be some functions like lat long to bucket, right? Simple. And he's going to give us a usize back. Yeah. Very, very simple. And so now all we have to do is basically, we know how many buckets there are on X. We know how many buckets there are on Y. If we do buckets len over buckets per row, that'll give us how many buckets are on Y. So we can say like num Y buckets, num lat buckets. Oh god, I'm gonna get so fucking confused by latitude and longitude, guys. I'm gonna get it wrong so much. And it's gonna cause all sorts of fucking problems. So I'm gonna work in terms of X and Y here. And then we'll make sure that we just map correctly at the end. Because I would hate to have like you know, a million bugs related to that. I guess maybe we actually just hardcode that as well. Yeah. Let's just do this. We'll just do 100 by 100. That's a lot of buckets. 20 by 20. And so here we actually don't need to allocate this array. This is just X buckets times Y buckets. Yeah. Okay. Sure. And then here we just, what's in this metadata? We can just kind of like yoink these. Like this. Maybe we just store a reference to the metadata, to be honest. That feels right to me. Yeah. Okay. Okay. So this gets initialized like this, and then all we have to do is store. All we have to do is store metadata. Then here, when we try to go lat long to bucket, we're going to take in the lat and the long. And we're basically going to try to like just linearly map this. So it's going to be metadata, self, metadata, max lat minus self metadata min lat. This over, this is disk. It's the lat minus the min lat over dist. Yep. This is the row. Thinking. Lat is flat. Long is long. What a stupid fucking thing. Latitude is vertical. Latitude is y position. So this is the row. Cool. So we're gonna do the same thing for lon. Max lon and min lon. It helps my brain thinking of lateral, which makes me think horizontal. Yeah, I mean, I think that's true. But the problem is you think horizontal and think x-axis, but that's wrong. Horizontal means y-axis because the flat lines are a change in y, not a change in x, but the x goes along the flat line. It's so confusing. It hurts my head. So this is over the lat distance, and the column is longitude minus min longitude over the long distance. Okay. Then we just, these are going to be U sizes. If in doubt, transpose. Brilliant. And then here we're going to int cast these. No, these are going to be float, int from float? Float to int from float. Okay. I think we're getting somewhere. I think that's most of the hard part, to be honest. I'd find the closest line statement for now and the extent of the streets. Well, the problem is that the metadata I care about is street related. So instead, I'm going to find a point on a street and then tie that back to a street ID. Longitude are points along the equator. Oh, I like that. That'll help me not get confused every fucking time. I think that might actually work for me. Okay, so this is going to be the bucket ID is the row times x buckets plus call. Then when we push a row ID, all we have to do is say lat long to bucket, given our lat and long. We say buckets at bucket ID. No, whoa. At the bucket ID, not the way ID. So we'll call this way ID here. Buckets lat long to bucket. Append way ID. So this is going to be failable. This thing actually does need to store an allocator because we are going to need to push to this thing when we append. We need to use our allocator because it needs some memory. Bro needs memory, so we need to give it to him. And this is going to be try. Oh shit, lat is y coordinate, my bad. Yeah. See, it's not simple. It's so confusing. I told you. And here we're just gonna get the same thing. So this is just return this. And this is buckets items here. Okay. That feels reasonable. Now, this isn't actually what we want, right? What we actually want is we want a singular ID. So actually, our buckets probably need to stash the position as well for each thing. And what we can actually do is we can store the point ID, and look that up later. I think that makes sense. Let me think. Oh no, actually this is fine. If we store the way ID, we can find out which points are along that way later. RXR Bin, thanks for the fucking raid. Look at you guys, so many raids today. Y'all are so kind. But for those of you who are just coming in, sorry for everybody who's heard me give this spiel like 4 times today, but for the 4th time, we're working on a map. The idea behind the map is that I want to be able to go from one place in my city to another place in my city without Google Maps pissing me the fuck off because he thinks that I can't walk 4 blocks, right? And so we are looking at what it would take to implement a path planning algorithm. But before we implement an algorithm to find a path, we need to know what paths are possible. We need to inspect a map. And so we have rendered this map, and now we're trying to figure out what the fuck these streets are. To figure out what these streets are, we need to be able to we want to inspect them visually because I can think about the city spatially. I can't really think about the city by node ID, right? So it would be nice if I could hover over this thing, extract some information. That's what we're working on right now. And so we're splitting this map into kind of like small areas so that we can pre-process this, look at like which points on this thing are in which box, and then when we look at the box, when we hover over the thing, we can like look at just that one box and say, well, there's like a couple hundred things in here. Let's just like rip them and see which one it is. And that should be fast enough. Fast enough. Okay. Okay. Constant raids a day. Never gonna be able to leave. Yeah. Yeah, we're gonna spend way too much time explaining to everybody what's going on instead of actually implementing it, and we'll never finish. Okay, so we should be able to store this way lookup here in our global state. We use global variables around here. Oh, fuck off. I accidentally closed my editor. Actually, only because we're in the context of WebAssembly, where these like WebAssembly modules being like instantiated one time and used from the context of JavaScript. So, you know, global state, not the end of the world. Not the end of the world. Now the problem here is actually though, some of this stuff is not constant data. So I don't actually know. We might have to kind of solve. Here's a loop. It's undefined. Fucking undefined. And then on initialization, when we call init, we'll just initialize the thing. So we should be able to say we are iterating our ways. I.e. streets, i.e. lines. For each line, we have. I actually don't remember what we made this do. It gives us a start and end index into the thing, right? So, way node IDs. Okay. So we can go from, I guess we'll call it a way. We'll go from for way start to way end. We have node index. So way is made up of a bunch of nodes. It's simple. It's simple, really. And here we're just going to say, well, we have a bunch of nodes somewhere, map data f32. And we're going to look at the node IDX times 2. Yeah, so map data f32 is a bunch of floating points that are arranged as like x, y, x, y, x, y. And so we need to do, here, we'll call this node index. Yeah. And we'll call this, we'll say that the node, maybe we'll call it node ID, then it feels a little bit less tricky. So we can say that map data index is node ID times 2. Then we say that the lat is, or we can call this lat index and lon index. And this is lat index plus 1. I think it's xy. So x is lon, so it's lon lat. Okay. Okay, so we have latitude and longitude, and then we should just be able to say, here we want to initialize the global way lookup init with the metadata. Guys, it's getting a little tough to manage, I'm not gonna lie. My head fucking hurts. We're gonna look at we're gonna say, fuck, this is actually global way lookup equals, way lookup in it like this. Okay. And then we can say that the global way lookup push way ID, which we don't have. Way ID plus equals 1. Okay. We push the way ID, the map data f32 at, was it lat long? Yeah, lat IDX and map data f32 lon IDX. There's a chance that this does something sane. Or else catch unreachable. Nico being like, this makes my brain hurt. I read it a couple times and I was like, I'm just not gonna acknowledge it because I don't know what the fuck he's saying. I gave up. Okay. Maybe I'm old school, but I'd create a composite object, and then from there it would be other types that would be derived from it: road, building, river. Maybe JavaScript does not support inheritance. I mean, it's not about that, right? We're not making data right now. We are trying to process data that already exists, right? So we just have we just have this fucking big ass XML file, right? And we're trying to be like, what the fuck is in it, right? And so this thing, so like this, right? This thing has like ways, and these ways have tags, and so we need to figure out like how to like extract these tags from this way. And the simplest way in my head to do this right now is just by like indexing into this way. Like, we'll store these tags somewhere, probably, and then we will index into like our list of tags later. Right, because we also have the like constraint that the way that we've like organized the way data is so that it's easy to render in OpenGL, WebGL, whatever the fuck you want to call it. And so it's kind of that's kind of how we arrived at like this way. Way, good one. So now at the end of all of this, I guess what makes sense is maybe we on mouse move, we try to look up where we are and say which way IDs are in this box. So here we'll just say like global way lookup get, and we have to like actually figure out what our fucking latitude and longitude of the mouse position is. So we have like the center of the screen here. Yeah, here, okay. So we have the center of the screen is here. Lat center and long center. And then we have this offset here. So this offset is in units of latitude and longitude. So let's just kind of calculate this and name it. So this is the longitude offset. This is the lat offset. Okay. And here we say minus equals long offset and lat offset. Now, this is actually fucked up. Why are some of these minus and some of these plus? Because I think that the Y movement is inverted or something. One of these is inverted. But we'll just call them both plus equals and invert this here, I guess. I'm a little confused about that. I think it's one of them is, yeah, one of the pixel spaces is upside down because I'm in the northern hemisphere or something. I'm not sure. Not sure. But you know, if the math works, the math works. We have to rotate the map. I think the map rotation was just because we flipped latitude and longitude, though. I think. Comment to point it out. Look, hey, don't you force me to have good code quality, okay? Because I want to hate myself later, okay? Okay, so here we can say that we are mouse lat is the global lat center plus the lat offset. Mouse lon is the whoa. Hold on. This is wrong. We're going back. We don't want this difference. Mouse down Y doesn't matter. This is where we started clicking and dragging. We actually don't care about this at all. We actually care about the X distance from the center. So we want like X norm distance from the center in normalized space is minus 0.5 because it's 0 to 1 over global zoom. Why is this global zoom times 2? Because OpenGL space is 2x. Okay, I think that's right. Okay, we'll try this. I'm not like 100% on this at all, but that's okay. That is okay. So this is going to be the lon, mouse lon. This is the mouse lat. Lat is flat, if you guys didn't know. And then we are going to just look up way look up mouse lat and mouse lon. Yep. And what are we gonna do with that? I would like to maybe say something like render ways. okay? And what we can do is we can just draw all of the lines. We can just highlight every single line that we see. So we'll call this way IDs. And I think it should be pretty fucking easy. I think. So we're going to take and render ways, and it's going to have way IDs, right? And we're not going to clear here. We are going to bind the same program, and we are going to set the same uniforms. That all makes sense. We don't need to clear, though. And we draw elements here, but instead of drawing all elements that we could possibly draw, we want to draw starting from the way IDs that we got in. So this is going to be like a bunch of usizes, right? And here maybe we're going to stash on initialization the way point IDs. So each way iter output. Okay, I think this makes sense. So basically we're going to make it so that we have the start and end of every single way, and then when we get here to drawing it, it's easy to just kind of say where those things are. So we're going to say for way IDs, we're going to look up the start and end in the global way point IDs of way ID. This feels right to me. This feels right. Okay. Then we just render from the points start to point start minus points end, or end minus start. That feels like it'll work. That feels like it might. But now we have to stash those things. So here, for each way, we are going to have to stash this thing that we got. So we're going to have like a std array list of way it output. And var way point IDs equal this, and it with std. Oh god, it's also hard. It's also hard. There's so much data to think about. Std heap wasm allocator for way point IDs dot dinit. Don't you have to change the line color size something so it's actually visible? I was just gonna disable rendering anything except for what is hovered temporarily. But yes, I agree. I agree. Eventually I'm gonna set a uniform on the lines, the fragment shader that lets me set the color or something. But for we'll get there, we'll get there, we'll get there. Give it a sec. Then, so for all of these things, we're going to say way point IDs append way. Catch unreachable. Jesus Christ, dude. The code quality is just absolutely fucking tanking. Oh boy, oh boy. So this is going to be equal to way point IDs to owned slice catch unreachable. I'll clean it up after. I promise, guys, I'll clean it up later. I promise. We'll clean it up in happy hour or something. But we just have to get somewhere. Fuck. Render ways has a. This can't be exported, which is fine. Doesn't have to be. Missing struct field waypoint IDs at 135, so we'll just kind of set this as undefined initially. That's fine. I don't care. Way lookup is not a function. That's true. It's not a function. So this is get here. 3 arguments on lat long to bucket. Because here I was supposed to type self on both of these. It's gonna be one long happy hours. Yeah. 261. We have to intcast this. And probably intcast this as well. God, if this fucking works, I'm gonna lose my mind. There's no fucking way. Expected 400 array elements, found 0. A7. So this all has to start as really? Does this not have a default initializer? It does. So do I have to do like do I have to do something clever? Like say we have one array one an element of one array list unmanaged multiplied by x, like x buckets times y buckets. Is this how I'm supposed to do this? Who knows Zig? Can they tell me if like what I just said was fucking stupid? Oops, this has to say usize here. Like, surely this is not how I have to initialize this thing, right? Surely not. Expected 1 array elements, found 0. Star star x times y. That is what I did. That is what I did. But it just feels silly. This feels like it should I should be able to like default initialize like every element automatically. But maybe that's just not how it works. He's mad that I'm missing allocator at 91. It's fine. We'll pass an allocator here. Which means that when we way lookup in it, we have to pass in our std wasm heap allocator, heap wasm allocator. I think that I'm gonna have to force myself to like decouple some of the wasm stuff from everything else because it's getting like really fucking unmanageable. So he's probably just crashing, just fucking. What is happening right now? He's stuck in some loop somewhere. We can probably assume that it's on initialization. Like, we can probably assume that if we comment this out, maybe if we just comment this out. I think this is basically the state we were in before, and that was fine. Yeah, so that's fine. And it turns out that doing whatever the fuck we were doing is expensive. So what happens if we do this? Why is it pre-processing again? Okay, whatever. So that was also relatively okay. It seems to be this loop that's really fucking slowing us down. Which, you know, would make sense. We could maybe look at, well, maybe we print here. Node usize node lat lon, and we say node id lon lat idx lon idx. Let's just kind of see what the fuck is going on here. Oh, did we just crash? Unreachable. Ah! Aha! We hit an unreachable. And those are just scattered everywhere because we're fucking idiots. So, we did get through, you know, maybe a few nodes. And it would be interesting to see what the fuck is going on. My guess is that this is returning an invalid ID. That's my guess. So we can maybe print hi and bye, just to see. So that's actually totally fine, surprisingly. Surprisingly, it's in between that. So it's actually not this at all. Is it this? Let's see. There's still an unreachable. Can we get like more information about this if we click on this? Like if I go, can I like say, yo, I want to catch an exception, pause. Okay, here we go. So we are in a default panic what seems to be maybe directly in our init function, right? He's like 1 deep. It's kind of hard to derive what the fuck is going on from there, but we could maybe just start commenting stuff out and see if it fixes itself. He has not fixed himself. Well, I don't see like the error is not being printed anymore. Oh, here. He actually still is. So it could be related to this iteration. But I don't really see anything that could trigger it in here. But, I mean, clearly if we do this, that's fine. And here we'll do if true continue. And we'll see if it still bails out there. Because if it does, then it's something about like the logic of iterating the different ways. Which I don't think, that's fine as well. It could be that way end and way start are not in the right order. Although this should always return end that is greater than start. Oh, fuck. Never mind. Never mind. Stupid little bug. Stupid little bug. So we're searching from I onwards. We're getting the index. And then that's causing problems. So, oops. Const end is equal to if and rel start. If this is true, then we give start plus v. Else we return self data len. Oops. Oopsies. It's kind of hard to tell. Okay, so that took a long time. We're also not compiling in release mode. So let's just see what happens if we do that. Optimize is equal to release safe. Let's just kind of get a feel for how long it takes to iterate all of the nodes. Refresh. Okay, so that's not too bad. Not too bad. That's like 1 Mississippi, 2 Mississippi, 3. Yeah, it's not the end of the world. It's not great. Definitely not great. But maybe not the end of the world. And let's go back to actually trying to actually extract, like, we commented some stuff out of that loop, and that needs to stay in there. I don't know where it was. I'm lost. Guys, I'm lost. Help. In it. Here. So it's here. We push the weight. And let's see if that still fucking runs. Because if it does, then we have all of our stuff bucketed, which is very cool for us. Oof. That's fucking slow. Holy shit. And it is just railing CPU right now. That's really fucking slow. So we might need to pre-process this. Yeah, so this is slow as fuck. Unfortunate. So what are the options here? Well, one is like the way we're organizing this data is like fucking stupid. Right? Like this array of array lists is pretty fucking slow. Let me think. It could be that this like concept of like doing this lookup at all is going to be slow. Like how much, I guess we're gonna have how many elements in here? We're gonna have, it's gonna explode in like complexity. Right? Like, because we're storing like way IDs for every single node multiple times. So we have like fucking like 4 million nodes, and we're indexing like each of them more than once, which is fucking stupid. I'm trying to think if there's like cheats that we can use to make this less fucking stupid, right? Because iterating ways is like reasonable. We can do that. There aren't a lot of them, but iterating nodes is fucked. That's a lot of nodes. That's a lot of nodes, and I don't think that we want to store every single one. So like, we could cheat on pre-processing. We could organize the nodes by bucket. So if on pre-processing, when we pack all of the nodes into our array, we can pack them according to their location. Ooh. I have to think about that a little bit. I think that's the way. Right? So how do we say this? So if we have all of our data, we have a bunch of nodes over, like this, scattered around the whole map, right? We can get clever and kind of make it so that all of these node IDs are smaller than all of these node IDs, which are smaller than all of these node IDs. Right? Then it's really easy. Then all we have to do is store the node indexes of each of these like bucket movements. And then that actually has a lot of other benefits too, right? Because it means that when we like iterate all of these node IDs, it's going to be like contiguous in memory, which is going to be really good. Now, I need to think about how that's going to affect us when we start looking at like a line going through here. That kind of gets more complex, but we can kind of apply the same trick to ways probably, right? Where probably like right now we're just kind of iterating the ways in the order that they come in the XML, but we can probably also store them in order of what they go through, except for the fact that ways are going to go through multiple, they're going to go through multiple sections. So it might just mean, like, it could just be that this is like expensive enough that we have to do it. We have to do it in advance. The other thing is, the other piece of information that we have is that we're fucking drawing all of this right now, every frame. It's like fucking instant to just on the GPU look at every single fucking node in the fucking map. And there's probably some way to leverage that piece of information to get what we want, right? Imagine we draw a 1 pixel image that is centered on the mouse. And we set the Z values of everything that we draw to be like distance from the mouse. Then whatever thing that is the lowest Z value will get drawn, and we could color it. Instead of coloring it a color, we could color it a way ID. That might be the easiest way to get what we want. Right? Like this spatial lookup, I imagine that anything that we do is going to be either expensive or take size in pre-processing. Or hold on, we could also do something else here. We could generate we could do this pre-processing step on the GPU. And then maybe we can like access the stuff from the CPU reasonably efficiently, but we just have to generate like the data that we're using on the GPU. That seems possible as well. So if we were to do that, we could have like these buckets, bucket. And for each way that we draw, we could okay, yeah. Hold on. So if you look at this like this idea of bucketing here, these buckets look suspiciously like an image, right? These are a lot like pixels. And oh, but you can't. I was gonna say that you could figure out which ways are in here, but each you need like a one-to-one mapping here, and this is like a many-to-one. You would have like many ways going through each of these, so that doesn't work. But maybe you could. There's probably some way to batch this shit so that you can like get like a texture output that represents some amount of processing. I just don't know what that is. I'll have to think about it. Yeah, okay. I'm going to think about this. I think that whatever the correct answer is, I'm not going to get to it today, right? We're already past what is usually the end of stream. So I'm going to call it there. But I think there's a lot of interesting stuff to think about. I think we made reasonably good progress today. Okay, let's go back to showing something that doesn't suck ass, so we can just kind of like if true return here. And run it again. Give him a second, he's gonna think. Close, reopen. Yeah, so I mean I'm pretty stoked on this. This is really cool. This is super fucking cool, right? So we've got a lot of map data. Oh, the other thing we could do is probably we could if we knew, well, I guess the whole point of us trying to pre-process this thing is trying to understand what is relevant information. So trying to like discard a bunch of information before doing any processing is like not what we want right now. Okay, anyways, I'm gonna think about it off stream. Thanks for watching, guys. I feel like we stream most days. We do happy hour at like 12:30 to 2, which is kind of like, you know, if you look at like what the code looks like right now, is not good, right? And so there is some amount of time spent cleaning up code and like kind of like making sure like we do like we'll say like 12:30 to 2. We call it happy hour, and it's like we're chilling, music's playing, we're doing cleanup. We're not doing like new feature development. We're just kind of like hanging out and trying to make sure that we're like in a good state. And then we have like main course 2 o'clock Pacific time to 4 o'clock Pacific time, which is kind of what you're seeing here, where we're trying to do like feature development, trying to make quick progress. So I call it like prototype mode, where you'll make decisions that are not best for maintainability, but are best for making progress and like experimenting. So that's kind of like the two things. You see those most days. Main course gets uploaded to YouTube. Like happy hour gets like archived on Patreon or on Twitch. What else? YouTube link in the Twitch description if you want to see previous projects. There's lots of stuff in there if you want to go check that out. GitHub link in the Twitch description, where you can see the code for this will end up in SFMAP. Discord link in the Twitch description if you want like updates about like when I'm going live and like when videos are posted and or just like chat about whatever. Yeah, I think that's all we got to plug. And let's say bye to people watching YouTube VODs and Twitch. Let's find someone to raid.